So welcome to the second part of lecture one. We're going to just continue our discussion of the real numbers and complex numbers in this second part, and we'll see some stuff that kind of ties back to what you would have seen in Math 1B03. Okay, so just carrying on for where we were before, just a quick reminder is I just kind of listed all the properties of f, where f is either the real numbers or complex numbers. This is how addition and multiplication works. And we just need some more notation that will be useful in the book. If I take any alpha inside of my field and I take any non-negative integer, when I write alpha to the n, what that means is alpha times alpha times alpha n times. So we'll see this notation from time to time. So it's just good to know what that is. And more importantly, throughout this book, okay, elements of f are called scalars. Okay, so when I talk about a scalar, what I'm referring to is elements inside of f. So f could be the real numbers or the complex numbers. Either case will be true, but when I talk about a scalar, I'm talking about an element belonging to f. Okay, so now let's move to my next slide here, page. And I want to spend a little bit of time talking about lists and n-tuples. Okay, so a list of length n is an ordered collection. Of n elements written as x1 in the first spot, x2 in the second spot, x3 in the third, up to xn into the last spot. Okay, so in some books or in the textbook as well, this may also be called an n-tuple, Okay, and I just want to highlight that lists and sets are two different things. So a list is not equal to a set. So in a set, the order does not matter, but in a list, order matters. Okay, so let me highlight this with a particular example. Okay, so remember we use curly braces to mean a set. Okay, so here I have a set, and inside of my set are three elements, 1, 2, and 3. And this set is the exact same thing as 3, 1, 2. Because both of these sets, we don't care about the order, both sets contain 1, both sets contain 2, and both sets contain 3. On the other hand, so these are sets, but if we were to look at lists, then the order is important. So we would want to differentiate 1, 2, 3, saying that is different than 3, 1, 2. Okay, so as lists. So be very careful about the notation. When you use curly braces, that means a set. When you use the rounded parentheses, that means a list. And when you write a list, things go in a particular order. Okay, so now we want to define one object that we'll see throughout this course is the set of all n-tuples of length n. So we have f to the n, and f to the n is going to be the set of all n-tuples, x1, x2, up to xn, where xi is inside of my field f, either real numbers or complex numbers, right? So here, this is all n-tuples of length n. Okay, so let's make this a little bit more concrete with an example. R2 would be the set of all things that look like x, comma, y, where x and y belong to my real numbers. Okay, so if you want to visualize, you think geometrically what this is referring to. This is referring to points on the plane. Okay, which is something you would have looked at in calculus. Now, one thing you want to notice is that we're using kind of very different notation that you would have seen in Math 1B03. So in Math 1B03, we commonly use column notation, right? We would commonly write r squared as x, y. So we would think about it as a 2-by-1 matrix where x and y are in R. So the notation is a bit different in this book. So we're always thinking of f to the n, or in particular r squared, is list, collection of lists. Whereas in 1B03, we were thinking them as columns, okay? But you can see that they're really the same thing, right? The decision is whether do we write them in a row or down a column, right? So in 2R03, we use the list notation. Nope, not the loss notation. We use the list notation. Okay, so it takes a little bit of getting used to that we're kind of like flipping everything, but it's just a different way that we decide to denote things. Okay, so keep that in mind as we're going in the course. And another thing that you want to keep in mind is that when we have a list, we sometimes want to pick out a particular element, and so the thing that's in the J spot, xj, is we call xj the jth coordinate. Okay, so that's so we can talk about specific entries in my list. So x1 is the first coordinate, x2 is the second coordinate, and so on. Now we're going to be needing to do operations on Fn, and again this should look very familiar from Math 1B03 where F was just the real numbers, but now we're doing the same thing for the complex numbers at the same time. So if we take two lists, x1 to xn and y1 through yn, okay, they're both n-tuples, we can add both of these n-tuples together, and we do it by saying by coordinate wise. So we take the first coordinates, and we add them together and we get x1 plus y1. That becomes our new first coordinate. Then we have x2 plus y2 and so on until we get to xn plus yn. Okay, so that gives us our new n-tuple, and scalar multiplication is done the same way. We take an n-tuple, a scalar c, and we can multiply our n-tuple by a scalar c by multiplying each coordinate by that constant. Okay, so again, this is something that you should have seen from Math 1B03 in the special case that F is R, but now we're making it work more generally. Okay, and we'll kind of finish up today's lecture with some more kind of things about notation, and we'll actually prove something in today's lecture.